what I do is to investigate or try to determine new methods of diagnosis so we could get faster diagnosis. My research focus is the investigation of arthropod-borne diseases, specifically rickettsial diseases. Working with diseases that are somewhat dangerous to most people, I find exciting because what you find is it's always new, it's different, and being able to apply that to other diseases or what you're working on, you can sometimes see an immediate health benefit. At one time, I wanted to be a forest ranger, starting off working in the woods because I had a great love of outdoors. Then I wanted to become a scientist because I was always asking why. And if I was not asking why, I was asking why not. I remember being a kid, maybe 6, 7 years old, trying to make an improved cleanser, taking all my mom's cleaning agents, mixing them together, which she had me take outside because it was stinking up the house. I actually started off as a chemistry major, and I found that chemistry did not like me as much as I liked it, so I changed to microbiology. This degree opens the door to basically anything. I've had throughout my career several mentors. Some of them were scientists and some of them were educators. And one of the things that I think I've picked up little pieces of their personality is to incorporate into my personality. But having someone who's older, who's interested, who is not only interested in your experiment, but interested in your development, that's always good. And I have had some mentors who are interested in both sides. I think what you're going to see is a combination of infectious disease and what I refer to as non-traditional aspects working closer together. Don't limit yourself to thinking along a certain line. Think outside the box. Look at a problem from different angles. Always try new things. And I think going out, trying new things, coming back, that always helps you with your problems. I've always found that some of my best ideas for new approaches come when I'm doing something away from the lab. Fishing, hiking, riding my bike, and I'll stop and have a eureka moment and say, I bet this is something that I could use. What I find most rewarding are the new discoveries. And sometime in the field of science, some of the discoveries you make, at the time they might seem minor, and a few months or a few years down the road, you've actually made a major discovery. That's exciting. I guess the overall message that I want to leave for young people is that using myself as an example, is that don't feel that you have to come from a certain high school or go to a certain college to make it. The high school I went to had 800 students. It was in a small rural area. I didn't go to one of the larger high schools in the state with several thousand students or a college that had 4,000 students in a graduating class. But I think no matter what educational institution you go to, you're going to get out what you put in. If you try to coast later on, you might have doubts about your abilities because you didn't push yourself. I think you need to go into a place, push yourself, see what you can do academically, socially, physically, so when challenges do come ahead later on in life, you'll be able to address them. You'll know what your capabilities are. The world is open to whatever you want to do.
I have a rather unique job. I am a veterinarian, as I stated, but I work in infectious disease and lab animal medicine. At Southwest Foundation for Biomedical Research, we're a primate facility. So as a veterinarian, my first obligation is to the animals. So the care and well-being of our animals is of the utmost importance, and that is my prime concern. One of my main duties is as the scientific manager for the Animal Biosafety Level 3 facility. When I'm wearing that hat, I manage the people and the projects and the experimental animals that we have going on in our Level 3 biocontainment facility. The type of work that we do is very important. As it turns out, I decided to go to veterinary school late in life, and while in veterinary school, 9/11 happened. And there was almost a palpable difference in our focus as young veterinarians in the field once that happened. Biosecurity now means protecting our population, protecting our food supply, and all of those things that go along with protecting from bioterror agents. And I knew at that point that that was something that was very important. I think being a veterinarian and taking care of pets is very, very important. I have Labrador retrievers, and they are like my children, so I need veterinarians to take care of them. We also need veterinarians to take care of our food supply, food animal veterinarians, and we need veterinarians to be in lab animal medicine to make sure that we have quality research conducted with animals so that we can better mankind and protect ourselves from the bioterror agents. When I was a youngster, I wanted to be a scientist and I wanted to work with animals. So it took me a long time to finally decide what I wanted to do when I grew up. For a while, I thought I would be an animal behaviorist because I was very fascinated by why animals do things. Then I thought I would be an evolutionary biologist because I wanted to understand at the molecular level why certain behaviors evolved. Then I decided to work in a research lab, and that was fun, but I needed more. So I went to graduate school, finished a master's degree, and still needed more. So I decided at that point that I would go to veterinary school because at that point I could conduct the studies that I wanted to conduct and still work with animals. So that's kind of how I sort of ended up where I am. And I would have to say I have a very busy job. I work long hours. It's not an easy job. It's very stressful. But fortunately, I have a very understanding and supportive husband who doesn't mind my long hours, doesn't mind my phones ringing in the middle of the night. Because I couldn't imagine myself doing anything else. So when I think back to what I wanted to be and what I am now, I think I'm getting there. I'm still young in my career, but I think that there's a very bright future for doing the things that I want to do, and I'm very happy to be where I am. Nobody wants to see animals hurt, and I like to say my job is to take care of the animals. So we know that the work has to be done. There's so many things, facets in everybody's life who'd be affected if it was not for animal research. But we do it in the most humane way possible. We have dedicated staff who works with animals. They get to know our animals so that they know right away if there's something wrong with the animals. My job, first and foremost, is to make sure that the animals are well cared for, because if you don't have well cared for, healthy animals, your research is not valid. I think if there's a youngster in there at the middle school age or high school age, they should read as much as they can. Listen to the news, watch the news, read the newspaper, read fun reading. Just because of reading, you gain knowledge. And if you want to do something in these fields, you're going to have to go to college. You're going to have to get an upper level education. There are so many jobs that are needed to be filled in the world of infectious disease research. You have to have people at the upper level who have the PhDs and the MDs who run the projects, but you also have people at mid-level who perhaps have a bachelor's degree, or people who do not have any educational experience whatsoever, but have a desire to learn. So in my field, we have people who take care of animals, and we have what we call animal caretakers, and you may think, well, that's just somebody who feeds animals and cleans up after them, and really that's not true. Our animal caretakers, I say, are our first line of defense, and we always need good people to do that sort of thing. And it doesn't matter whether you have an education or not. With time, you learn your job, you excel at your job, and it's noted, and you move up. Being a woman in research is not an easy thing to do. I think that we have to work a little bit harder to balance family life with our careers, and it's important to have a partner or a spouse who's very supportive of what you do. That's first and foremost, and I'm lucky to have that. I don't have children, so that's one of the sacrifices that I may end up making. I have dogs, And at this point, I just haven't had a chance to have children. And so that's something that will either happen in the future or it won't happen. But at the same time, if it doesn't happen, I won't miss that because I'm satisfied with my career. And I think I have to work just a little bit harder than what a man would have to do, simply because people don't often think of women as working hard to make a living, because it's not traditionally what women do. But I think as we move further into this more modern world, we see more and more women in the field, especially in veterinary medicine. Most schools will have a predominant female class, and it's becoming a more female dominated world, which is interesting, because you still have the old ranchers who don't really want to see girls come and take care of their cows and their horses. But people adjust, and I think if you have a desire to do a job, you should do it and never let anybody tell you that you can't. I think that a researcher in any field faces dangers. So our first line of defense is that we wear what we call PPE, personal protective equipment. Our second level is we have rules of how we approach the animals and how we work with them, and if you follow the rules, you're not going to get hurt. Thirdly, I work in the level 3 laboratory and also the level 4 laboratory, and so we have additional PPE. We have procedures that must be followed so that we have the maximum safety for the personnel and for the animals. We work in teams where everyone knows what the other person is capable. We know what the other person is doing at all times, so that there are no surprises. So in that sense, I feel just as safe working inside the level 3 or the level 4 as I do getting in my car and driving in the highway. Skills that are necessary to be successful and happy working in a laboratory would first and foremost be motivation and dedication to what you do. We have people who don't just do the minimum that's required of them, people who are always thinking of how they can do things better, and people who are always thinking of what can be done instead of sitting around doing nothing. So we have people who are dedicated, who are motivated, who are bright, forward-thinking people who want to make a difference.
Well, I'm an immunologist by training, so we study the immune system, and at UTMB we work on zoonotic diseases, which are diseases that are transmitted from humans to animals and potentially from animals to humans. And we work on vaccine development and the development of therapeutics. The immune system is a protective component of the defense that you have to protect yourself against the pathogens that we're embedded in on a daily basis. And what the immune system does is it makes a discrimination between what's self, what's part of you, and what's not self, which are potentially foreign agents or other molecules. And so the body struggles to eliminate those foreign objects, whether it's a pathogen or whether it's an allergen or whatever it happens to be. And so that's what we study, is how the immune system functions. I had a lot of influences in my family and in my neighborhood where I lived. And so my first goal when I went through high school and middle school was to become a clinician. I thought I could make a more significant impact by doing research and developing new therapies. I have a younger son who's in 6th grade now, and he brings home immunology problems in some of his biology work. I know that I didn't have the opportunity to do that when I was his age. So I think the curriculum, at least based on the 2 teenagers that I have at my house, has advanced, and there are a lot more opportunities to discover that. But what I did was try to take in as much biology, chemistry, physics, those types of things as I could when I was in primary school, and then to prepare yourself to go on and do more advanced work in college. So that's how I prepared myself. I'm originally from Southeast Texas, so I went as far away from home as I could get and still be in the state. So I went to Texas Tech University, which is in far west Texas. And I did a combination degree there. I did a microbiology and a chemistry degree, and then I ultimately went back to graduate school, and I did that at Texas A&M University and the genetics area program that they have on their campus. And as it turned out, the person that I ultimately went to work for was in the College of Veterinary Medicine, and that's where I started working on infectious agents as a model. And so we started out working on a rabies project looking at immune response genes and how they controlled immunity to rabies, because when vet students first come in their first year of training, they all get vaccinated, and they would go back and evaluate all the vet students, and there were a certain proportion of the students who are non-responders to the vaccine. The training in immunology can be a little prolonged, and I think there's some stick-to-itiveness. You may get a little bit frustrated at times. I have 3 students who are close to finishing now, so I know where they're coming from in terms of wanting to finish up and be independent and progress through their career. So I guess the training period can be a little bit long. At times you're doing exciting work and it's very challenging. I think that there are a number of opportunities available at various levels at the bench, and also to do translational work, moving products out of the laboratory and into humans or into animals, whatever area that you wanted to be in. But I know that in my own area, we're always looking for bright, motivated individuals who are interested in doing this type of work.
I want to do everything. I was determined to be an opera singer, and I failed at that. But eventually, after working a lot and I enjoyed the stage, I did all sorts of different things. It wasn't till later in life I decided I wanted to study medicine. My interest in medicine, I really became determined later in my mid-20s. And it was very, very difficult because at that time in the 1960s in England, women were not generally admitted to medical school. 15% of the places were given to women and the rest to men. So it was a very, very big struggle to get admitted to medical school. And a lot of people told me it couldn't be done. But I love that, because if someone tells me I can't do it, that's like a challenge to do it. So that's what I eventually did. Well, there was a moment before I went in when I said to myself, what am I doing with myself? I was boiling an egg at the time, and I remember looking at this egg and said, is this all I'm doing with my life? I've got to do something else. I've got to justify the fact that I exist, and that really mattered to me. Infectious diseases were forgotten. After around about the 60s, 70s, we thought we had antibiotics, we had vaccines, we didn't have to worry anymore. But the real problem is that these agents, viruses and bacteria, are so adept at getting around what we do that they find a way to come back at us. And so really we got caught unsuspecting when AIDS hit us. And there's been a resurgence of infectious diseases, and we must not forget them. But I think one of the most important things to pay attention to is that generally infectious diseases are diseases of the poorest people. And for that reason, we've always worked in developing countries with poor people. And that is a very rewarding thing to do. People who are going into the field now are going to have to get a lot of different skills, and they're going to have to collaborate together, because it takes a team of people now, because not one person cannot do anything anymore. So it's very, very exciting, very, very challenging now, but a very, very rapidly moving field. What I love now, why I still enjoy my work, is I'm always learning something new. It's always interesting. And people pay me to do it. I can't believe my luck. Our lives are longer than they used to be, and so they don't have to be in too much of a hurry. But back to the principle, do the best you possibly can. Learn the difficult subjects, learn them as well as you can, even though it's a pain while you're doing it. But get that knowledge and get the best grades and into the best school you can, and then you will find that the opportunities just open up for you. My parents didn't think it was important for a woman. His parents didn't have the resources to do it. But you can do it. There's always someone who can help you. It's out there. It's hard work. But the hard work's very rewarding. And eventually, as you start to understand things better and better, it's not just rewarding, it's just a lot of fun.
A lot of people do think that what we do is risky. But, for us, we've been doing this for a while, and when you do your training, you progress through different levels of hazards as far as biological agents go. You start off with, level 2 viruses, which are, not really all that dangerous. You can get sick, but it's not necessarily going to kill you. Then you move to level 3, which are a bit more dangerous. And, of course, with the level 4 viruses, they're really dangerous. But, when you're trained properly and when you're working in the proper environment, it's no more dangerous, really, than working in BSL-2. The only real difference is that if you do something wrong, the result is not usually very good. But when we work in that lab, we're very careful about what we do, and I've never really been concerned about my immediate health. I mean, as far as the things we work with, I mean, certainly the first time you pick up a vial of something that is going to kill you if you mess up, I mean, it definitely gets your attention. I mean, you couldn't even imagine doing some of the experiments that we do now 20 years ago. I mean, in fact, even 5 years ago, some of the stuff like one of the project in my lab is looking at the structure of a virus, and in order to do the calculations to figure out the structure of the virus, we have a pretty powerful computer working 6-8 hours at a time to do the calculations. And the Atari or TRS-80 I used when I was in high school certainly wouldn't be able to do that. I mean, everything was on a single floppy disk. So it's hard to guess where science is going. I think certainly in the nanotechnology fields is a direction that things are going to go, and also maybe a lot more in the bioinformatics and a lot of more of the genetic manipulations, these sort of things. I think that's probably the best bet. But if anybody really wants to pursue a career, I mean, there's no sense in. I mean, just getting a basic fundamental training in biology is a good place to start. And then if you want to move into something else later on, you can do it a lot more easily if you have a good the good fundamental training. I think the best way for students to prepare themselves, and I actually tell this to my students now, is that the more well-rounded you are, I think, is the better of a scientist you're going to be. I mean, and that means even if you're doing physics or you're doing chemistry or you're doing biology, the more things you know how to do and know how to do well, I think in the long run makes you a better scientist, because when the questions come up, you know how to address them. And so, the one thing I would discourage kids from doing is doing just one thing. People who know how to do one thing really, really well, and then they get themselves in a position where, golly, I have to understand how something else works, and they have never had any background or experience. So I think when you're in college, even if you want to do physics or you want to do chemistry, it's always helpful to take a couple other classes and learn how things work, and how you can apply what you're learning into real life situations. And I think that's important. My interest in this research started sort of a long time ago. It hasn't been a very direct route. I sort of got here the long way, as it were. But my interest in science goes back a long way to 5th and 6th grade, and had some pretty cool teachers in high school. And then when I was in college, I was at a school that had a big program that looked at these kinds of viruses. And then I kind of had an interest there and learned some stuff about biochemistry and disease and things like this. And then went to grad school and did something completely else, and then came back. And I was fortunate to get a job here at UTMB, and then sort of just progressed from there. It's something that I've, I guess in the long run, I've really become a lot more interested in, and it's a lot of fun. Well, as a middle school and high school student, my dreams were quite a bit different than where I ended up. I mean, I initially wanted to be a veterinarian and do that sort of thing, but then I realized that probably wasn't the best career for me, and I just sort of, in a lot of ways, just sort of fell into what I'm doing now. I didn't really say, oh gosh, I want to work in a high containment lab. I want to work with these nasty viruses, because really back in that time there weren't that many viruses well known, and it wasn't that big of a deal. And so I sort of just kind of fell into it. And as you're going through your career, things just sort of take a progression, and if you just follow it, this is sort of where you end up. And I don't have any regrets at all about where I've ended up. And so it's sometimes I think just letting nature take its course, as it were, is just as much good as saying, this is what I want to do, I'm going to do that. Because sometimes if you do that, I think you also limit what you can do. I wouldn't say I had any mentors that motivated me to go directly into infectious disease, but certainly had a couple in high school that got me into doing science in general. I mean, I had a chemistry teacher who was a lot of fun. He was about 2,000 years old. I remember distinctly the funnest class was making peanut brittle in class. I'm not sure you can do that anymore, but doing things like that where they made science fun, and you learned and it was fun, and that's what really was the driving force for me to want to do science in general. I think the thing I find most rewarding about being in science or being in science is when you find something new. And a lot of the stuff, we work really, really hard, and that's one of the things, junior scientists also have to learn is you work really, really hard, and things don't usually work or come out the way you expect. I mean, and that's usually that's normal, so it's okay. But when things actually work and you find something new or something really interesting, I think that one day in a month or one day in 2 months or whatever it is, that's when it's really, what is really rewarding. It's like, gosh, I've never seen this before, and I wonder how that works. And it's never really a, I've saved the world kind of moment. It's more along the lines of, oh, that's pretty neat. Okay, what's the next question? How does this tie into something else we're wanting to do? And for me, it's not, it's like not like a grand prize at the end of the day kind of thing. It's more along the lines of, as long as for me, it's always being stimulated intellectually and always being able to ask questions about how something works. I think for me, that's probably the most rewarding thing about it. If there's something that you really want to do, and for example, you want to go to graduate school, maybe your grades weren't so hot or whatever, keep trying, and eventually you'll get there. And I think that's the one thing that if you work really, really hard to get what you want, then you'll get it. I believe that, and it's especially for kids, and don't ever get frustrated with the way things are going or what people are telling you. You got to stick to your guns and do what you want, and don't tell your parents I said that.
Right now, the type of work I do is a combination of administrator, because I'm a regional dean of a small new campus of University of Texas School of Public Health down in Brownsville, which is along the Texas-Mexico border. And the other part of my job is a scientist. And right now I'm working on the interaction of diabetes and infectious disease, and particularly looking at the interaction of diabetes and tuberculosis. My education was probably fairly typical, although I went to this really small high school. I only had 42, I think, in my graduating class. And I had, as I mentioned earlier, was very interested in science. Went on to this little college in Florida that gave me a scholarship. And there I took every science course and every math course that the school offered. So I had actually a double major in chemistry and math, a minor in physics, and a minor in biology. And I worked in the summers and took courses so that I was sort of absorbed in all of this. And then I went off decided to go teach school for a while, mainly just to get some experience. I didn't know what the rest of the world was like. I grew up in a small town, and I felt like I didn't know much about what was going on out there. So I went off to Africa, and when I was teaching high school science and math, and there was a hospital nearby, and two American physicians showed up at the hospital to reopen it. Now, this was an area that had been involved in the civil war in the Congo for several years. So the schools have been closed, a lot of problems, there have been people killed, missionaries have been killed, teachers have been killed. So I went back and opened up the school along with some other colleagues, and then this hospital reopened. And in the process, I did some work for the hospital. I rewired it because the wiring had been torn out. I fixed a lot of the equipment, including an x-ray machine and other things. And the physicians started taking me on rounds. I'd never had any experience at all with medicine or anything. And one of them said, you ought to think about going to medical school. So he actually ordered, and I took the medical college admission test out in the Congo. And then we sent it back, and fortunately I got into a good medical school, Duke University, and came back to go to medical school. So that was kind of my experience in medicine, but that really prepared me for public health. And I knew that I wanted to do research because I'd always been interested in science, but it also focused me on public health in a real way. And I went back to medical school with a lot of experience and a little more confidence than a lot of my classmates had, which was good for me. I find a number of things rewarding about what I do. One is the opportunity to work in different cultures and to learn how to communicate in those different cultures and to build some bridges between those cultures. I find that enormously rewarding. I find learning every day and interacting with young people who are excited to learn and being able to sit down and hash out a scientific problem to be enormously rewarding. I've built a number of programs in my time in various parts of the world, and many of those programs are still in operation and still going. That's enormously rewarding. And I've made some discoveries that have made a difference in treatment and in diagnosis and other areas like that, and I find that also quite rewarding. I think we're in the golden era of medical and biological sciences, and we're in an era where we're going to learn more than we've ever known before about the very basic mechanisms of disease and infection. And so it's an exciting time because young people can, if they work hard, can become scientists, and through this kind of work can really make a difference, because we're going to discover new vaccines, new treatments. We're already doing that. We're going to discover how to deal and prevent cancer. Maybe the most important thing of all is we're going to learn how to prevent most of this. And we're going to figure out how to do that. And that will be a very exciting time. And I think any young person who wants to have an exciting career and one that's really interesting, this is a great way to do it. Let me say, I mean, sometimes people say, well, I want to go to business school or whatever.